is to finish off the floating point lecture. And then I'm going to move on to the lecture that's called Objects. And we'll learn how to make objects in Java and use objects. So far, everything you've been doing in the lab, you haven't really been making any objects or creating objects. You've been more or less doing what you did in your previous courses, where you'd make something that looked like functions, and then you'd call the functions. So that's all going to start to slowly change now. OK, so we got to the cancellation slide on the last lecture. Right? So when you take two floating point numbers and subtract them, right, you end up with what's called cancellation. Right? You lose the significant digits, which is not surprising, because that's how subtraction works. Right? So here, I've got a 10-digit number, lots of significant digits. I got another 10-digit number here. They're almost equal in value. So when I subtract them, I lose a whole bunch of significant digits. Right? So the difference here has only one significant digit, even though the two arguments, or the two operands, have many more. Right? OK, so that's called cancellation because, well, you lose the leftmost digits, right, which are called the significant digits. Right? OK, now if you subtract two numbers, two floating point numbers, and the floating point numbers are exact, right, then it's just the result of this. It's just the result of the difference. So yes, you get cancellation. But there's no harm in the fact that we've lost digits when we've done the subtraction, the difference. Right? So that's called benign cancellation. There's a second type of cancellation called catastrophic cancellation. Right? And that happens when both of your one or both your operands have error in them. Right? And you've seen already from the previous lecture that whenever you do anything with floating point numbers, there's probably error built into the number. Right? We can't represent most real numbers in floating point. If you do any arithmetic operation with two floating point values, there's probably error in the resulting in the result. So if we try to compute two values and then use them and subtract them, that's where catastrophic cancellation can occur. Right? So here I'm going to compute b squared minus 4ac. Right? So the part under the square root in the quadratic equation. Right? Now I have to compute b squared, and I have to compute 4ac. Right? So the odds are very good that when I compute these two quantities, I'm going to lose digits. Right? So let's pick some values b, a, and c. Right? They all have 3 digits, right, in them, so I can write them down in our floating point format. Right? I'm going to calculate the result exactly, right? So using real math. Right? So 3.34 squared is 11.1556. Right? That product there is 11.1246. Right? If I compute the true difference, right, it's 0.0292, right, which is 292 times 10 to the minus 4. Right? So in this example here, I can actually represent the true difference in our floating point format. Now what happens if I actually compute these using our floating point format? Right? Well, I don't have 6 digits, so I won't be able to represent this number or that number exactly. Right? So let's do that. So b squared, I know it's 111.556 times 10 to the minus 1. Right? In our format, we've only got 3 digits. So I have to lose the 5, 5, and 6 somehow. Right? You can either throw them away, or in this case, I'm going to round them so that I produce a smaller error in this case. Right? So if I round that number to 3 digits, it's 112. Right? If I round the second number to 3 digits, it's 111. Right? Now when I compute the difference, I get 100 times 10 to the minus 3. Right? So that's my result. Now compare that 100 times 10 to the minus 3 to the correct answer. 292 times 10 to the minus 4. None of the digits in the calculated result are correct. Right? The 1 is wrong, the 0 is wrong, the 0 is wrong, and the 3 is wrong. Right? All 4 digits in the computed result are wrong. Right? Which is surprising, right? It's weird that happens. Right? If you compute the absolute error, right? So when I subtract the two values, y is at 1,000 times 10 to the minus. That's 29. Oh, that's correct. Right? So when I compute the error in ALPS, right? That's 292 times 10 to the minus 4. Right? 100 times 10 to the minus 3, I have to make the exponents the same, so that's 1,000 times 10 to the minus 4. Right? Subtract them, that's 708 times 10 to the minus 4. which is 708 Alps, right? Which is enormous, right? Because the intermediate results, right? That one and that one, there's only a half Alp error there, right? But when I compute the difference, right, suddenly I have 708 Alps of error. Right? And so that's the effect of catastrophic cancellation. Right? Subtract two approximately equal values where one or both values have error in them, then the result is likely to be very inaccurate compared to the true value. Right? Now, every once in a while, you'll be computing some quantity using a formula, and it turns out that you can manipulate that formula to remove the catastrophic cancellation. Right? So that's not, I'm actually not going to do any examples of that in the course. If you want to look at the floating point notebook, though, there are examples of when you can do this. So in the notebooks, you can actually try out these equations and see what happens when you use the original equation versus the transformed equation. Right? When you use the original equation, the answer is completely wrong. When you use the transformed equation, you get something that's closer to the right answer. Right? So in your copious free time, you can take a look at that if you want to. No one's going to ask you about it in this course. Okay. All right. Now, so whenever you do a calculation with floating point values, there's some error. So now the question is what happens if I do a whole bunch of operations? Right? Do the errors compound? Do they cancel? Do they do something in between? Right? And the answer is you don't know. They can compound, right? Or they can cancel out. Right? So every basic operation potentially has 1/2 Alp in error. Right? So if you repeat that operation over and over and over again, right, that means you can potentially accumulate that half Alp error however many times you perform the operation. Right? Now, when do you have to repeatedly perform an operation? Well, when I want to sum a bunch of elements, for example. Right? So if I want to compute the average of a large number of results, right, or compute the standard deviation or some other statistical quantity, right, that involves large sums. So what happens when you do this? So here's a simple example of when you can get something that's completely wrong. Well, not completely wrong, it's wrong. Right? So here what I'm going to do is I'm going to take an array that has 1,001 elements in it. Right? The first element is 1,000,000. Okay? The rest of the elements are 0.1. Right? So I've got 1,000 0.1s. Right? Add them all up in your head, you get 100. Right? 100 plus 1,000,000, 1,100,000. So that should be the result. Right? If you actually run this loop, right? Here I'm using float instead of double because it's easier to show the result using float. Right? If you actually run this and print the result, you get 1,125,000. Right? You can't even add 1,000 numbers up and get the right answer. Right? The answer's quite a bit off, right? 25 units off, which I think to most people would find that very unusual. Right, that the computer can't even do this calculation correctly. Right. Okay, can we fix the problem? Right. So, surprisingly, in this case, it has an easy fix. Right. Instead of the 1,000,000 being at the front, I'll just move the 1,000,000 to the end. Right. So move the 1,000,000 over to the last element of the array, compute the sum, and now it prints out the correct answer. Right. And you say, well, that's really weird. Right. But it shouldn't be weird. Right? Shouldn't be weird. So what happens back in the original example? Right? I start out with 1,000,000, and then I add 0.1 to it. Right? What do you know happens when you add a large number and a small number together? You lose part of the small number. Right? So the first sum is already wrong. Right? So now I've got a large number. It's approximately 1,000,000, and I add another small number to it. I lose part of that small number, and now the sum's even worse. Right? So now the errors are compounding. By the time you've added up 1,000 small numbers to 1,000,000, you get the wrong result. Right? You've lost so much of the result that you've lost 25 units from the correct answer. Right? Why does it work when I flip it around? Well, when I add 0.1 and 0.1, they have the same magnitude. So when I add them together, if there's any error, it's likely to be very small. Right? Now I've got a small number plus 0.1. So when I add those together, their magnitudes are roughly the same. Right? And so now in this case, the errors compound, but they compound much less quickly. By the time I get to the end, I've got a number that's basically 100 plus 1,000,000. Right? And the difference in their magnitude, while it's large, it's not the same as the 1,000,000 and 0.1. right? And so there, in this case, you get the correct result. So sometimes you'll see, so if you actually search for this on the internet, you say, I've got a large number of values that I need to sum, and I want to sum them in a way such that the resulting sum has the least error in it, right? And so one of the things, one of the pieces of advice that you'll see is that you sort your array or your list of values, right? Sort them from smallest to largest and then compute the sum, right? Which is basically what I did here, right? So it sort of works. Doesn't always work. It sort of works, right? What's wrong with it? Well, now I have to sort, right? So if you write a method that actually does this, right, and then you try to share it with the rest of the world, right? Whoever calls your method with their array, right, your method ends up changing their array, right? It sorts their array, which they probably don't want, right? If they're asking you for the sum of the values in the array, they're not expecting you to sort the array on them, right? So can you fix that problem? Well, yeah, you can copy the array, but now you're taking up twice the amount of memory, right? Also, if you sort the array, right, sorting is much slower than summing the values in an array, right? So you've done some complexity, right? Yes? Okay, so you should know that sorting is the fastest sorting algorithms, fastest general purpose sorting algorithms run in O(n) log n, right? So you have to sort, then you have to sum. So now you have an extra O(n), right? Whereas summing n values, that should just take O(n), right? So sorting then summing is more than twice as slow as just summing, at the very least, right? And so it turns out someone actually figured out how do you sum a bunch of numbers together without sorting the list or the array, right? The person who figured it out is someone by the name of, last name is Kahan, so it's Dr. Kahan. I forget his first name. He was a prof at U of T in electrical engineering. He's also one of the people who wrote the IEEE 754 standard, and he's also a Turing Award winner. So he's won the highest prize in computing science, mostly in part for his contributions to numerical computation, right? So everything I've talked to you about, it turns out it is enormously important, right? Although most programmers aren't aware of of a lot of the implications that I've told you about in the previous lecture. Right. Okay, so that's it. That wraps up the floating point part of this course. So at this point in time, you should have an idea of how floating point numbers are represented, right? What are the implications of the fact that we only have a finite number of digits when I compute with floating point numbers? All right, any questions about floating point stuff? Okay. All right, so it is possible to make a large Java program doing only what you've been doing so far in the labs, right? So in other words, you can write some methods, some static methods. You can write a main method somewhere. You can put some data in your main method, and then you can just call your functions to do something, right? And if you really wanted to, you could write a gigantic main method that computes some very complicated result, right? So it's possible to create a Java program using mostly the primitive values, right? And just a single main method and just a bunch of other methods, right? But almost any non-trivial Java program makes extensive uses of objects that interact with one another, right? Now, why do you want to do this, right? So if you remember what an object is, right? It's something that's got data in it, right? And it also knows how to operate on that data, right? And so if you have objects, it makes it possible to perform operations, perform other operations that you can't do just using primitive values on their own, right? Or at least perform other operations that you can't do easily with just primitive values, right? So objects contain information stored in variables, right? The variables are called fields or instanced variables, right? I'm going to call them fields in the course, right? So every object has fields. Your fields, they can be primitive types, right? So an object can have an int in it, for example, right? But they can also be reference types. So an object can contain another object, right? Objects can be made up of other objects, which are made up of other objects, and so on, and so on, and so on, right? And so it becomes easy to very quickly build very complicated objects, right? By having objects contain other objects. Okay, so the set of values of the object's fields, right? So if you look at the fields of an object and you just look at their values, that's called the state of an object. Right? So I'll give you an example of that shortly. So objects can perform actions, right? So what that means is objects have methods. So if you're given an object reference, you can call a method on that reference, right? And then that object can perform some computation on the data that it has, right? Furthermore, objects can call methods belonging to other objects, right? And so that lets objects communicate with one another, right? And then that way you can perform very complicated tasks. Okay, so to make an object in Java, the programmer has to make one, or call a method that makes one, or do something, right? They have to do something that creates an object. Once you have a reference to an object, you can use it, right? So you can call methods using that object, right? And then at some point, when you're done with the object, that object has to be destroyed, right? Because the object takes up memory and other resources. So in Java, so in C, you would create something dynamically using new, using malloc, right? Or calloc or something like that, right? And then you would release it using free, right? So in Java, you don't care about freeing the object, right? So we don't care about step 3, right? Instead, the Java virtual machine takes care of getting rid of unused objects, right? So we're worried about creating them and using them. So how do you create an object in Java? You use the new operator, right? Which you've already done when you make arrays, right? To make a new array of double, you write new double square brackets some number, right? So the new operator actually does 3 things, right? It allocates memory for the new object, right? So for your C programmers, it mallocs some memory, right? So it allocates memory for the object, right? It then calls something called a constructor. Right? And the constructor, when the constructor runs, it initializes the state of the object. Right? So in other words, it fills in the fields belonging to that object. Right? It sets it to some values. Right? And then new returns a reference to the new object. Right? So when you make a new array, you end up, new returns a reference to a new array. Right? When you make a new object, new returns a reference to a new object. Okay, so in the notebooks, if you go to the relevant part, if you go to the appropriate notebooks, if you go to the objects notebook, you'll come across this class called point2, which for all of you should be a class that makes a lot of sense to you. So point2 represents a 2-dimensional point, right? So it has some an x and a y coordinate, right? And the x and y coordinates are both double values, right? So this slide here is an example of how you can make 3.2 objects. Right? Oops. Okay. So here, point P1, right? I can write new. Right? Then the thing after new is a constructor call, right? So this is a call to the point2 constructor. Now it looks like a function call to you, right? The name of something followed by round brackets. Here it's round brackets and there's some arguments in it. Right, so this looks like a function call. It's actually a constructor call in Java. Right? The name of the class is called point2. So it turns out the name of a constructor is always the name of the class. Right? So if I have a class called foo, then the name of the constructor would also be foo. Right? And the class can have multiple constructors. Right? So this first constructor makes a point whose coordinates are 0, 0. Right? The second one, if I pass in 2 double values, you get the point whose coordinates are the double values. Right? The third one, I pass in a reference to another point. Right? So I pass in the point P2. Right? So that third constructor copies whatever the coordinates are of P2 and gives you back a new point having the same coordinates. Right? So that's called the no argument constructor because it has no arguments. The last one is called a copy constructor because it copies another point2 object. Right? The middle one doesn't have a special name. It's just a constructor. There's a class called scanner that's often used in introductory Java courses. So a lot of the way a lot of people teach Java is they make you write a main method and then you type some stuff in. Right? You run the program and then you have to type some stuff in. Right? So you have like a calculator or something silly like that. Right? if you want to read the keyboard input, you can use something called scanner to do it. Right? Scanner is actually java.util.scanner. Right? So if I want to make a scanner object, I write new scanner. Right? So that's a constructor call. If you want to read the keyboard, you have to read standard input, which in Java is system.in. Right? For C programmers, it's just standard input. Right? You can also write a scanner to process a string. Right? Or sorry, you can create a scanner that processes a string. So here we make a new scanner object, right, and pass in a string that the scanner object can scan. So you can use the scanner object to scan that string and pull out the 1, the fish, the 2, the fish as separate strings. Yeah?
So there's the scanner, you're creating scanner object, but
yep.
Are you calling a scanner class?
You mean here, when you write new blah?
Yeah.
Yeah, so that thing there is actually a constructor. Right? The name of the constructor happens to be the name of the class, because that's the way it works in Java. Right? So you're not calling a class, you're calling the scanner constructor. So that's actually what's happening here. Okay, so when you use new, it's always followed by a constructor call unless you're making an array. Right? If you're making an array, then it's just the type of the array that you're making. It looks like you're calling a method, right? Or it looks like you're calling a function in C. Right? The language specifically says, right? The standard for the language specifically says constructors are not methods. Right? So, and in particular, right, a constructor never returns a value, not even void. Right? In Java, all methods return a value or void. Right? Constructors never return a value; they never return void. Right? So that's the so there is a distinction between a constructor and a method. So the constructors are defined inside of a class, right? Because everything's defined inside of a class. So inside the point2 class, that's where you would find the definition of the constructors. Right? Constructor names are always the same as the class name. Right? And what's the purpose of a constructor? So the purpose of a constructor is to initialize the state of the newly created object. Right? So in other words, when you make an object, it's important that you set the object to some well-defined or well-behaved state. Right? In other words, you have to give it its field some sensible values. The thing that does that is the constructor. Right? So remember that, right? Remember that's why I'm calling a constructor. Okay. Many classes, not all, have a no argument constructor. Right? So the no argument constructor is the constructor that has no arguments. Right? So the no argument constructor for point2 is just point2 and then nothing inside the round brackets. Right? So what's the purpose of that constructor? So the purpose of that constructor is to initialize a newly created object to a well-defined default state. Right? So if you make a point2, if someone asks you for a point2 object, right, you're going to give the point2 class gives you back a point2 object whose values are whose coordinates are 0 and 0. Right? They're not random, in other words. Right? Not every class defines a no argument constructor. So you have to look at the documentation for the class to find out what the constructors are. A class that has a copy constructor, a copy constructor is a constructor that copies another object of the same type as the class that it's defined in. Right? So here, right, the copy constructor for point2, the type of its argument right here is also a point2 object. Right? So a copy constructor for a class copies an object of the class and returns a duplicate. Right? A new object that's the same as the copied object. Right? Oh, sorry, not every class defines a copy constructor, right? Not no argument, right? So class doesn't have to define a copy constructor. Again, you have to look at its documentation to find out if it does. And again, so a class can define multiple constructors as you've seen, right? The point2 class has at least 3. It may have more. I don't remember anymore. So point2 has a constructor that lets the caller make a point with the coordinates that they ask for. Right? So that one lets the caller make a point whose coordinates are 1 and 0.5. And there is an example of scanner. Right? So here we make a scanner that can scan the keyboard. The second one, we have a scanner that can scan a string. Right? All right. So once you've called the constructor and gotten an object, now you can use the object. Right? So calling it using new plus the constructor, that is the birth of the object. Right? Once you've got a successfully birthed object, now you can use the object, right? So to use the object, you're going to call methods, right? How do you call a method? You take a reference to the object, dot, name of the method, pass in the arguments, right? So in other words, it's like calling a C function where you're passing in the name of, where you need the name of the object to call the function. Right, so here's an example of using a point 2 object. Right? So I make a point 2 object, its coordinates are 0.5 and 0.1. Right? Point 2 has a non-static method called x. Right? X returns the x coordinate of the point. Right? So p dot x returns the x coordinate of the point referred to by p, which is 0.5. Right? P dot y returns the y coordinate of the point p, which in this case is 0.1. Point 2 also has a method called x that takes in a double value, right? So it's got one that doesn't, it's got a method x that has no values. It's got a second one that takes in a double value. The second one changes the coordinate of x, the x coordinate of the point, right? So p dot x followed by 0.6, right? Changes the coordinate of point P to 0.6. Yeah, questions?
Could you do, like after you've done the new point 2, could you do P equals point 2 and then create, or could you have to use the P dot set?
So, run that by me again.
So you've created like the point 2P, and then you said that to change both coordinates, we have to use the P dot set. Could we?
If you want to change both at once, in one step.
Could you instead just call the point 2 constructor again?
No.
Okay.
Well, sorry, if you call the constructor again, so if you write P equals new point 2, some new point,
Right.
you now have a new point object. So now you have a second point, right? In some cases that might work, right? So if I don't need the original point, right, I just need a point with the coordinates that you want, that would be okay.
Would you always have to call the new point 2 every time?
Every time you make a new point, yeah, every time you make a new object, it's always new followed by constructor call. Yeah. So px and py, if you pass them in a double value, will change the coordinates of the point, right? If you want to change both coordinates of the point, you just call set, right? And set will change both coordinates of the point at once. Okay, so what can you do with this? Well, I mean, once you have a point, right, you've got something that you can move around, right? So this little program here makes a point, right? Starts at 0.5, 0.5. Right? We've got a variable here called the radius. We're going to set that to 0.1. Right? dx, so this is the change in x. So I'm going to change the x coordinate of this point by 0.01 each time. Right? And then I've got a loop here. Inside the loop, all I'm doing inside the loop is I'm moving the ball back and forth. So I'm changing its x coordinate by dx. When I get to the right-hand side of the screen, I'm going to negate dx so it moves to the left. Yeah?
What's the final? What are the double?
Good question. Why do I have this thing final, double, and then why is this in capitals here? Right? So if you have a variable that's marked final, right, that means that I can only assign a value to the variable once. Right? It doesn't mean that the variable is constant. Right? It means I can assign a value to it once. So final double radius equals 0.1 means that the value of radius is always 0.1. Right? You're allowed to write final double radius semicolon, and then somewhere else assign a value to radius, right? When you assign a value to it, though, you can only do it once. Yes?
When you assign a value to it, do you have to make it a double?
Yes, because its type is double. Right? Yeah. Now, it's in all caps, right? If you ever see anything in all caps in Java, it's probably a constant, right? So in this case, the radius. In this case, by making the variable by making the variable radius final, it is effectively a constant in this case, right? So that's why it's in all caps also. Yes?
Do globals work for Java?
There's no globals. Everything belongs in a class.
Right.
Yeah. All right, so the rest of this stuff is just some simple logic that makes the thing go back and forth on the screen. Standard draw, that's the class that, if you're in the lab today, that's the class that was used to draw the picture. Right? It's just a class that lets you do some simple drawing. Right? So if you run this program, if you have the course notes, if you have the source code for the course, you can create this program. Right? So in the default package, just make a program called something like bounce, right? Copy in the code, add in the import statements so you import the right classes, right? And then when you run the program, you get the ball that bounces back and forth, right? Add some paddles and then you've got Pong, right? And then, so it doesn't take much more to actually turn this into a game of some kind. You can do more complicated things with points. So the bouncing ball example, this is already created for you. So again, if you've downloaded the course notes, right, where to go? In this package here, there is a program called Bouncing Ball, which is here. I'm not going to look at the source code for now. I'm just going to run it. You get this. So the ball bounces up and down. So this is just, all that's happening here is the ball is moving under the simple projectile equations, right? Which you all know from your first year physics course, right? And this just bounces around forever. Right. Okay, so here's another example of using objects, right? So I'm going to make a scanner object, right here. Right? The scanner object reads the keyboard input, right? So that's what passing in system.in to the constructor does, right? Now the scanner has this method called hasNextLine. HasNextLine returns true if the scanner has one more line of input to return back to the caller. If the scanner has read a line of input, right? Now it turns out if you're reading standard input, this is always true, right? It's always going to, is that true? HasNextLine? Yes, I think that's always true, right? So it's just going to sit there. This will run forever, right? So next line returns the line. So if you type something in and press enter, and then ask for the next line, you get the line of text that was entered, right? And so this then prints out the line of text that was entered. So this thing just runs forever. You type something in, press enter, it just repeats it back to you. Oh, this one's better. So this one runs until you type in quit and then press enter, right? If you actually run this program and you need to stop it, it's Control-C on your keyboard. If you look in, if you're running it in Eclipse, there's also be a little red square by the console that you can press to stop it. Right. So this one will run until you type in quit or Control-C, and then it'll stop. Oh, here we go. So this is where you learn how to read documentation for a class, right? So when you go to use objects, you have to find out, well, how do I use this object, right? So one way to do it, of course, is just to do an internet search of some kind. But at some point, you have to learn how to read the documentation for a class, right? So all of the Java standard library classes, they're documented online. So if I click this link, skip variation, right? This takes you to the documentation for version 8 of the language, right? Okay, so up here, this is showing you all of the classes. Yeah, this is showing you all of the classes that are part of the standard language. It's enormous, right? So there's literally thousands of classes here, right? Sorry, these are the packages, these are the classes. So literally thousands and thousands and thousands of classes, right? So that's not very useful. If you're trying to find something in this list here, it's going to take you forever, right? So it's a little bit more useful to know how the packages work in Java. Okay, so what are packages? So packages is one of the mechanisms Java uses to organize its classes. Right? So there's a package called java.lang. Right? Inside java.lang are the classes that we've been talking about so far for the most part. Right? So things like math are here. String is here. Right? What else have we seen so far that would be here? We've seen like integer, right? So integer is here. Right? And so on and so forth. If you click on one of these, this is where you find the documentation for the class. Right? So there's the documentation for the math class. At the beginning of the documentation is a description of exactly what it is the class is meant for. Right? So this tells you the class math contains methods for performing basic basic numeric operations. There's a lot more detail here, right? If you go through it. If you keep on scrolling, sometimes you'll find something called the field summary. right? And you'll see that there is a field called E and a field called pi in the math class, right? You'll find their types over here, right? So the type of pi is double, the type of E is double, it's static. So if I want to get the value of E, I can write math.e. If I want to get the value of pi, I can write math.pi, right? If you click on one of these, it'll take you to the documentation for the field, right? So it tells you what is pi? It's the double value that's closer to any other to pi, right? The ratio of the circumference of a circle to its diameter. If you actually want to know its value, you have to click on that. So if you click on that, it tells you pi is that number there in Java, right? And E, that's Euler's number, right? That's 2.718 is that value there. Right, go back. Okay, so what else is in this thing here? Okay, so for the math class, there's no constructors in the math class, but there are a bunch of methods, right? So there's a method ABS. So up here, this is the short description of each method, right? Notice that you get the type of the return value here, right? If you click on ABS, it jumps to the long description of the method, right? And now you can see the full header of the ABS method, right? It's public, static, returns a double value, right? And its name is ABS, takes in a double value, right? What does it do? Well, it returns the absolute value of the double value. What else does it tell you? It tells you what is that parameter, right? A, the argument whose absolute value is to be determined, right? If it returns a value, it tells you what is the value that's returned. If it throws an exception, there will be something down here that tells you what type of exception is thrown and when. Which one of these does throw an exception? It may not be, I don't remember if any of the math methods throw an exception or not. Oh, wait. Throwing an exception, here's one. Decrement exact. This one takes A, returns the value that's equal to A minus 1 if it fits in the range int, right? So if you give it integer min value, this throws an exception, right? And tells you right there, right? So it throws an exception if the result overflows in int, right? So the documentation, so number one, the documentation for Java is, in my opinion anyway, much better than the documentation for any other language that you'll find, right? If you actually go and look up the official C documentation, it sucks to read. If you look up the Python documentation, it sucks to read. Right? The Java documentation, by comparison, is much easier to read. So it's super useful, right? The way that they've, and it's standardized, right? Which is also very useful. Okay, so at some point, you're going to have to get used to reading the documentation for Java classes, because that is the standard documentation for each one of the standard classes, right? Now, if you're going to use a class for the first time, the documentation is not so good, right? The documentation doesn't have any examples in it. So if you're trying to figure out how do I use this class to do something, right? That's when you search, right? And you look for some tutorial page somewhere, right? That shows you how to use the class, right? All of the classes in the course notes. Where's Eclipse? Here, right? So if you have this course source code, it's all documented, right? You can find the documentation for this. Is it here? Right? Under the doc folder right here. Right? If you click on index.html, you can find the documentation for, oh, that's not right. That's in the wrong place there. Oh, that's also in the wrong place. Go back. That's opened the wrong thing. That's linked to the wrong thing for some reason. This one give me the right one? Oops, sorry. Oh, these are all screwed up. I guess I have to rebuild the documentation. They are all here though. If you look in here, in each one of these folders, you'll find the document. Yes, you'll find the documentation for each class. So for example, here, right? You can also get to the documentation from the notebooks, right? So you have the documentation for all the classes that are part of the notes. Okay, do I want to start this? I think the answer is no. I think we'll stop here. and we'll talk about lists in the next class. Lists are souped up arrays. So they're the more useful version of an array in Java.